Hello, grade 12. This is Mr. Mayaya. Welcome to our third lesson of Geography grade 12 tutorials, ITP. And today we are looking at tropical cyclones. Now, you're already familiar with what is a cyclone, okay? So, namhlanje sigena another type of cyclones. So, let me not waste more time introducing the topic. Let's just get started, guys. Okay, tropical cyclone is displayed, but I'm going to simplify this to you just like I did before. You remember how I introduced our mid-latitude cyclones? So I'm going to do that, but a bit differently this time, okay? And why am I doing differently? It's because you already know what is a cyclone by now, guys, okay? Please do not disappoint me. Also, has routine the cyclone, yes? Very good. So let me explain to you why are these cyclones called tropical cyclones. So they are called tropical cyclones because they are found within the tropics. Wait, what are tropics? When you talk about tropics, we are talking about areas that are found within the boundaries of 26 degrees to 26 degrees. So all of this area here, and this would be your, yes, very good, this would be your 0 degrees equator. Says one. So yonke le ndawo le, this area is known as tropical areas. Says one. So this is where our tropical cyclones are going to be found. Okay, but just know that this is where our tropical cyclones are found. But we're going to change these numbers a bit and going to say 30 degrees here, and we're going to say 30 degrees nalangezansi. Hey guys, sorry to patch in like this. So this guy forgot to tell you something that's very, very important before he starts with the lesson. He can't start the lesson without telling you the objectives of the lesson or what you can expect from the lesson. So I'm just here to do that, then I leave. So by the end of this lesson, that's the thing that you're supposed to have learned. So we're going to look at the general characteristics of a cyclone, just like we did previously with the mid-latitude cyclone, right? So this is where I'm just going to mention general characteristics, like the topic says, anything that applies to tropical cyclones. Then we're going to look at areas of formation, where exactly these cyclones form, the tropical cyclones. Then last, we're going to look at, yes, the recipe now for tropical cyclone. In order for a tropical cyclone, what is the recipe, or what are the prerequisites for it to form? For example, there needs to be high temperatures, there need to be high humidity, and so on. Then we cannot get into details now. So what is it that you need to know with regard to a tropical cyclone? The very same thing we did with mid-latitude cyclone. We're going to look at general characteristics. So this is where we are saying anything that you can say about tropical cyclones, okay, that applies to tropical cyclones. Now, first of all, very important to remember, these are similar to mid-latitude cyclones because they are both low pressure systems. Okay, but here's the first difference. This one, we say they are powerful spiral storms. So this one are much more powerful because even when we are looking at the impacts, we're going to concentrate more on the impacts of tropical cyclones. What kind of damage does a tropical cyclone impose on people, on the land, on the nature, and so on? But we're not going to delve more into the negative effects when you talk about a mid-latitude cyclone. We did not concentrate that much on. So these one are much more powerful storms. Number two, the intense low pressure system. So these ones are much more, so this point is much more similar to the previous one. So these are powerful intense low pressure systems. They're much more stronger than the mid-latitude cyclones. Now they consist mainly on 3 parts. There's another 4th part, but I'm not going to mention it on my lesson. So that consists of 3 main parts. The first one being the eye. Wait, an eye. What is an eye? So let me jump right straight into an image, guys, so that you can see what a tropical cyclone looks like before we continue with this part. So this is how a tropical cyclone looks like. So as you can see around here, we've got clouds. All of these now, these are clouds. So when we talk about the eye, this is what we are talking about. This is what we are talking about. This is your eye. Okay, so that is the first part of a tropical cyclone, the low pressure, warm, calm, cloudless eye. cloudless because now it consists of less clouds compared to the surrounding areas here. There are less clouds here. Okay, so it also consists of the eye wall. So just right straight next to the eye, there's what we call an eye wall. It consists of tall, towering cumulonimbus clouds. Now, uzokhumbula from our previous lessons ukuthi ama-cumulonimbus clouds, the larger clouds. That's ngathi mina, it's because they've got a long name. That's how you can remember what it cumulonimbus large clouds. Yes. Okay, so this, because we've got these tall clouds here, this is where we're going to experience the heaviest rains. Because we've got tall clouds and huge clouds, this is where we're going to experience the strongest rainfalls and winds. And the third part of our cyclone consists of spiraling bands of rainfall, of rain. Because while the cyclone is rotating, guys, bear in mind there are three main things that are rotating them. The first one being water. Water is rotating because, remember, this cyclone occurs within the ocean. The next thing that's going to rotate there is going to be the air, wind in this case. The wind is also rotating there, and also the air. Sorry, it's water, wind, and clouds. Yes, water, wind, and clouds. So those are the three things that are rotating in our cyclone. Right, so because it's a cyclone, you know what is going to circulate clockwise, just like in the mid-latitude cyclone, clockwise, but only in the southern hemisphere. They rotate in the clockwise direction. Okay, so then obviously they are going to rotate anti-clockwise in the northern hemisphere, just like with mid-latitude cyclones. Right, so it's cyclone yethu, guys. So this is our tropical cyclone image, as I've already shown you. So remember what we said about mid-latitude cyclones. Mid-latitude cyclone, they move from west to east. Mid-latitude cyclone, we said they move from west to east. But when it comes to tropical cyclone, they move from east to west. Says what? They move from east to west. So this is what this means. They travel westward. Westward means from east to west, from 5 degrees to 30 degrees. So they are pushed by easterly winds. They have got a lifespan of about a week now. They can last up to a week. So if a cyclone has occurred at a certain area, rainfalls can continuously pour within that area for the whole week because of the storm. Alright, now next, let's look at areas of formation where these cyclones form. You already know by now these cyclones form at a 5-degree latitude, then they start moving towards the 30-degree latitude. So when they move from 5 to 30 degree, remember they also move from east to west. These cyclone, guys, next thing that you should know, they are named differently according to which ocean they are formed. Even though it's the same thing, but they are named differently. So if a cyclone is formed from the Indian Ocean, which would receive our cyclone from the Indian Ocean, it is called a cyclone, which is why we're calling them tropical cyclones here in South Africa, because we receive our cyclones from the Indian Ocean. Now, if a cyclone is formed from the Atlantic Ocean, it is known as a hurricane. So people in America, they call their cyclones hurricanes because they receive their cyclones from the Atlantic Ocean. Then those ones that form in the Pacific Ocean, they are known as typhoons. The cyclone dissipates, guys, when it reaches cooler latitude or when it reaches the land. Let me explain this very quickly. Some of the prerequisites of a cyclone is high temperatures. In order for a cyclone to form, there needs to be a high temperature. So if there are no high temperatures, the cyclone is going to die. Let me draw this simple diagram of the globe here. So this is our 0 degrees. Here, let's say this is our 30 degrees. So a cyclone forms here at about 5 degrees, then it start moving in a westward direction. All right, while it moves towards the 30-degree latitude, you can see what it loses the heat. Close to the equator, it's very, very hot, so there's a lot of heat there that is going to provide energy for a cyclone to form. So the more it moves towards 30 degrees, the cooler it becomes. That's why it's going to dissipate, because it's no longer receiving evaporation that is going to form those clouds. Why does it dissipate when it reaches the land as well? It's because of friction now. In the ocean, it is just a flat surface, so a cyclone does not collide with anything in the ocean. So, but when it reaches the land, there are mountains, there are trees, there are buildings. The land is not flat. So, cyclone while it's rotating, it's not going to collide with buildings or trees or mountains, which is going to cause it to die. That is friction. Next, let's look at the conditions that are necessary. What is it that has to be there in order for a cyclone to form? First of all, they need to be high temperatures, warm sea surface temperature. Why do we need high surface temperatures? It needs to be hot in order for evaporation to occur. Remember, we said it consists of tall cumulonimbus clouds, but before those clouds form, it needs to be hot so that we can have evaporation. That's why we say high sea surface temperatures. Next, we say there needs to be high humidity. Now, obviously, because it's very hot, the air is going to rise, because in the ocean, the air that is rising, it contains moisture, which is going to form the clouds. It needs to be convergence of winds. From grade level, you'll remember that where there is convergence. So here you can see I'm drawing this. So we've got low pressure here. So where there is convergence, you'll remember what this is where we experience warm rising air, right? That means our pressure is going to continue to drop. That's what we mean by to create a low pressure. Convergence of winds that is going to cause the air to rise, therefore creating a low or intense low pressure. Then next we need to have a steep pressure gradient. Now let me simplify this like this. Let's say this is our 30-degree latitude, which is our subtropical high. So it's a high pressure, right? So the more the air continues to move there, the more we've got convergence there, the more a pressure is going to drop there. Then eventually we're going to have a steep pressure gradient. For example, let's say I were to draw a table to represent this. I were to draw a table. So you can see what this is a table. This area is a bit higher here. Let's say this is about 5 meters. Here it's about 3 meters. So you can see our gradient here is a bit gentle, right? But now what happens when the pressure continues to drop here? Fine, they say, okay, here it remains 5 meters. Now here, because the pressure is dropped here, now let's say this is 1 meter. What happened to the pressure gradient here? What happened to our pressure gradient? So now our pressure gradient is steep. The more the wind is going to move towards the low pressure, right? So obviously now to remember this, if I were to put a ball here, then it rolls down this table. Then I put another ball here, it rolls down this table. At which table is the ball going to roll faster? Very good, here. So a wind is going to move faster because of the continuous decline of a pressure here. Then lastly, we need to have a strong Coriolis force in order for a cyclone to form there about 5 degrees. That's what is going to cause the cyclone to start rotating. Now this is where we're going to end our part 1 tutorial of tropical cyclones, guys. But don't worry, we're going to do part 2, which is going to look at the stages of development from stage 1 up to stage 4 and more. So stay tuned for that one as well. And I'll see you next time. Bye bye.